Welcome back. In the past lecture, we learned about the derivatives of three primary trigonometric functions: sine function, cosine function, and tangent function. We said that the derivative of sine of x is cos x, the derivative of cos x is negative sine x, and the derivative of tangent x is secant squared of x. But you know that other than these three trigonometric functions, sine, cos, tan, we have three more. We call them reciprocal functions. And I wonder what the derivatives of those functions are. In the textbook, they didn't mention these, but we just don't care about the textbook. We just do our own thing. All right, so y equals. So I have here secant of x, and I wonder what is the derivative of secant of x, okay? To find the derivative of secant, this is what I'm going to do. I'm going to write it as 1 over cos of x. It's true. And then I'm going to apply the quotient rule. Derivative of top is 0 times bottom, and then minus derivative of bottom, which is negative sine x, times top, okay, which is 1, okay, divided by cosine squared of x. Okay, I applied the quotient rule. So if I simplify, I get sine x over cosine squared of x. Okay, I can rewrite this in the form of sine x over cos x, okay, and then times 1 over cos of x. Can't I? I can. But now, sine over cos, if you think about it, is tangent of x, and 1 over cos, reciprocal of cosine function, is the secant function, right? So that means that the derivative of secant of x is actually tan x times secant of x, right? We derived another formula. I'm going to add it to my list. So if y equals secant of x, the derivative is going to be secant of x times tangent of x. For the cosecant of x, okay, I'm not going to do it, but I suggest you do it. You do it by yourself using the same technique you just learned. And the result would be negative cosecant of x times cotangent of x. That's the result. And I trust you would do it by yourself. You would derive it. You would prove that formula. And finally, we have cotangent of x, which is a tangent function. Derivative of cotangent of x, I'll just give you some hint, but you do it just like the tangent. You write cotangent of x as cosine of x over sine of x, and then apply the quotient rule. I trust you will do it. Final answer will be negative cosecant squared of x. All right, that will be the final answer. So now I have 6 derivative formulas here for sine, cosine, tangent, secant, cosecant, cotangent. You can find the derivative of any trigonometric function basically. Now I want to combine chain rule with these 6 trigonometric derivative formulas. I want to combine them and come up with sort of shortcut formulas for you, okay, which will be very handy in future. So let me put it this way. If you have y equals sine of, let's say, square root of x squared plus 4, okay, how would you find the derivative of this function? Well, if this was only sine of x, you would say the answer is cos x. But now it's sine of some function of x, right? So we have to apply chain rule basically. And this some function of x is just playing the role of u for us. So derivative of sine with respect to x would be derivative of sine with respect to u, which is cosine of u obviously, times the derivative of u with respect to x, or the so-called u prime. So in order to take the derivative of this function, I'm going to say, okay, derivative of sine of u is like cosine of u. So I go cosine of x squared plus 4 under the radical sine, but then times u prime, which is the derivative of this radical itself. And the derivative of radical itself is going to be 2x over 2 square root of x squared plus 4, but you can simplify 2 and 2 in the bottom and top. So you get x over square root of x squared plus 4. Bingo, done. That is the answer. To formulate this idea of combining chain rule with trig derivatives, I'm going to write down here, I'm going to say y equals sine of u. And what does u stand for here? U is a function of x, just like this squared function. So sine of u, the derivative of sine of u is going to be u prime cosine of u. I gave you some shortcut formulas, very handy, very useful, combining trig derivatives with chain rule. Okay? So now you can find sine of any function, not only sine of x, but sine of radicals, sine of like quotients, sine of like products, sine of polynomials, you just name it. Sine of any function can be found, like the derivative sine of any function can be found by this simple formula. Similarly, y equals cosine of u, the derivative is negative u prime sine of u. Then we have y equals tangent of u, whose derivative is u prime secant squared of u. You know where this is coming from. I'm getting the ideas from the original formulas that I proved earlier. And these formulas are not in the book, but be my guest. You know, that's what friends are for. I give these shortcut formulas to you so that you learn and use them and enjoy actually using them in future calculations of yours. Y equals secant of u. The derivative is u prime. That comes from the chain rule. And then the formula, secant of u times tangent of u. Y equals cosecant of u. The derivative is negative u prime. And then cosecant of u cotangent of u. And finally, y equals cotangent of u. The derivative is negative u prime cosecant squared of u. So there you go. You have all these nice formulas that you can apply. I may, of course, use the time here instead of giving a separate lecture, quickly give you a few examples, okay? What is the derivative of tangent of square root of x? Okay, tan of u. The answer is, cheating from here, u prime secant square root of u. So u prime is 1 over 2 root x times secant squared of square root of x. Done. You see how simple it is if you master the formulas. Another example, sure. Y equals x cubed secant of x. Okay. So here, what you see is a product of a polynomial or a cubic, function and a trigonometric function. So it reminds me of product rule, u times v. The derivative of u times v was u prime v plus v prime u. So this is u prime v plus v prime u. Derivative of first times second plus derivative of second times first. Very simple. So derivative of x cubed is like 3x squared times secant of x. And derivative of second is derivative of secant, cheating from the chart. It is secant of x tan x times the first function, which is x cubed. You see? Done. Finished. As simple as that. Of course, if you can simplify by finding some GCF, that's fine. You better do it. For example, I see here x squared. Secant of x is a common factor. So I'm going to say, okay, I'm going to factor it out. So I get like 3 from the first term. And from the second, I get plus x, x tangent of x. There you go. This is the final answer in simplified form. So example number 1, example number 2. Why not example number 3? So for this one, I can select, for example, cotangent of 3x squared plus 5x minus 1. So cotangent of a quadratic function. Who would think one day that you would be taking the derivative of such weird functions? So y prime is going to be u prime with the negative sign in front, so minus 6x plus 5. Okay, that's negative u prime. And then derivative of cotangent of u is negative u prime, cosecant squared of u, right? So it's going to be cosecant squared of u. There you go. So 3x squared plus 5x minus 1, done. As simple as that. Example number 3, finished. More examples? Sure, we can do more examples. Let me see. Y equals 1 minus sine x over 1 plus sine x. Okay, so this is nothing but a quotient, isn't it? So I'm going to apply quotient rule. Derivative of top times bottom minus derivative of bottom times top divided by the denominator squared. So the derivative would be, derivative of top is negative cos x. So that's derivative of the top times the bottom, 1 plus sine x, minus derivative of bottom is cos. So cos x times 1 minus sine x all over the denominator squared. 1 plus sine x, the whole thing squared. So we get y prime equals distributive law, negative cos x minus sine x cos x minus another cos x plus sine x cos x, because negative times negative is positive, right? Got to be very careful. Denominator again squared. Terms cancel out each other, sine x cos x. So I end up with negative 2 cos x in the numerator, and the denominator 1 plus sine x all squared. There we go. Simplified answer, final answer for the derivative of 1 minus sine x over 1 plus sine x. Okay, I give you 4 examples, and you have to practice as much as you can to become very fluent in trigonometric differentiation. Okay, I wish you all the best.